Okay, I started out with 1, 2, 3, 4, 5, 6, 7 simple equations. All these things are solvable by applying laws of algebra and a definition of an absolute value function. So, 5-minute synopsis. Solve x squared equals 16. Well, one way you can solve this is say, well, x has to be the square root of 16 or the negative square root of 16. Because, of course, when you square a negative square root of 16, you're still going to get 16. So by common sense, you have this, which means x is 4 or x is negative 4. Your solution set, therefore, is negative 4. A set negative 4, 4 with the braces. Okay, I'm going to give you some problems like this. They can be done in a minute or less. If it takes you longer, okay. If you got to ponder the laws and really make sure you understand the laws, okay? But you got to get to where something like this you can solve not by knowing that 4 squared is 16, because if it was 17 there, you wouldn't know what the number is, would you? Okay? Applying these laws would tell you if this is 17, that x is the square root of 17 or negative square root of 17, right? And if you wanted a number for that, a decimal number, you'd have to go to your calculator, because you don't know how to do square root of 17 any other way. I used to, I don't anymore either. I know a long way of doing it. But, okay, an alternative in solving this, take the square root of both sides. Okay, raising both sides to the same power, to the 1/2 power, right? So the square root of x squared equals the square root of 16. What's the square root of x squared?
X.
Is it always x? Well, I'll show you here that it isn't. Although that's, probably what I would have answered my first year of college. And then I thought about it, wait a minute. Okay? X squared isn't necessarily x. What if x is negative 3? What do you get when you square negative 3? 9. What's the square root of 9? 3. Is that equal to x?
So
No, x was negative 3, but the square root of negative 3 squared is 3, right? So I go through that in some detail here. So you might want to look at that part of the video. The square root of x squared is not x, unless you know x is positive. Now, if you're on a domain where all x's have to be positive, then you're safe. But if you're dealing with all real numbers, all you can say is the absolute value of x is equal to the square root of 16. The square root of x squared is the absolute value of x. Okay? And the absolute value of x isn't always equal to x, is it? You give me a number whose absolute value is not equal to itself? Well, if x is negative 2, what's the absolute value of x? 2. Is that equal to x? No, the absolute value of x is not equal to x. It's equal to negative x. If x is less than 0, the absolute value of x is negative x. If x is greater than or equal to 0, then the absolute value of x is positive. It's equal to x. That's the definition of absolute value. I'm almost sure you've seen it, but it probably isn't important for the SOL, so it never got emphasized. Another gift of a multiple choice test used to determine school funding. Bad idea, but maybe not worse than the alternative. Okay. So there's shortcomings, like this whole definition of absolute value. That's a little bit weird. I thought it was a little bit weird the first time I saw it. So you probably think it's a little bit weird too. But that's what it is, so you might want to look at that part of the video where I talk about it a little more. So anyhow, absolute value of x is 4. If the absolute value of a number is 4, then that number's either got to be negative 4 or 4. Everybody would agree, right? So x could be 4 or x is negative 4. Another way of solving this. And I'm going to ask you to do a solution of an equation like this. Show me the steps and probably explain some of the reasoning. Okay? Because unless you can explain the reasoning, you're not going to remember the steps. If you can explain the reasoning and it makes sense to you, then you're not going to have to practice on 1,000 problems. You do a dozen problems and explain them and you've got it. And it's not going to go away from you. At least if it does go away, it's not going to go far away. Okay? So, those examples. Now, how do you solve x minus 6 squared equals 25? Somebody want to give me a suggestion? What operation can you do on both sides to make progress? Square root of both sides, right? Square root of x minus 6 squared is what? Sorry?
X minus 6.
Absolute value of x minus 6 for the same reason the square root of the square of any quantity is the absolute value of that quantity. There are two values of x that would make that true, as we'll see. If you take the square root of both sides, that's fine. But the square root is the absolute value of x minus 6, right? Which means that x minus 6 is either equal to 5 or it's equal to negative 5. Either way, its absolute value is going to be 5. Okay? And you want to think about that until it makes sense to you. Now, if x minus 6 is 5, then it's easy to solve that and add 6 to both sides. You get x equals 11, right? And if x minus 6 is negative 5, you add 6 to both sides, you get 1. And those are your two solutions. So your solution set is the set using braces for the set consisting of the numbers 1 and 11. Those are your solutions. Okay? Next equation was x squared plus 4x plus 4 equals 0. Now we're going to see another way to solve this equation. But what everybody did in MCR is they just factored it, which is great. You can factor this, but if I put a 5 there, you can't factor it anymore. Okay? If I put a negative 5, you could factor it, but 5, it's not going to factor. Okay. At least not in any way you can discover. Anyhow, this factors into x plus 2 times x plus 2. Okay? Now you got to be careful when you factor this. You just go on? No, you stop and multiply this out using the distributive law and make sure you get what you've got here so you know you factored it correctly, right? A lot of error checking as you work through problems. You always check everything that you're not 100% sure of, and since you can't be 100% sure of anything, you check everything. Okay? Or at least you check your final answers and make sure you got them all. Okay, well, and that's, again, how you learn by doing a dozen problems rather than 1,000. You don't just drill it into yourself because you're going to forget that. You understand why you're doing what you're doing. You might forget it, but you're much less likely to. And again, if you forget it, you don't forget it that bad. You can usually bring yourself back. Okay, anyhow, you got that. Now that only works for one possible value of x, it turns out. What is it? You can look at it and see what x has to be to make that 0. Somebody want to tell me?
Negative 2.
Again?
Negative 2.
Negative 2. Because that makes this one 0, right? It also makes this one 0, but it doesn't matter. If this one's 0, the whole thing's 0, right? Because you're multiplying. Okay? Only works if x plus 2 is 0. Means then x plus 2 equals 0. If you subtract 2 from both sides, x has to be negative 2, right? Just to do it by formal algebraic steps. And that's the only number that solves the equation. Okay? There's another way we could have solved that using the quadratic formula. And we're probably going to get to that in a little bit. Okay, your alternative. You could write this as x plus 2 squared equals 0, right? And what do you do to that? We take the square root of both sides. What's the square root of x plus 2 quantity squared?
The absolute value of x.
Absolute value of x plus 2. And that equation breaks into two equations. X plus 2 is either 0 or it's negative 0. Of course, negative 0 is the same thing as 0. So in this case, you only get the one solution, although for most absolute value equations, you get two solutions, right? So, you have this. Okay, how about x cubed equals 8? Now you can, if you know what a cube is, you know that x equals 2. You cube 2, 2 times 2 times 2 is 8. Well, that's great, but what if this is 9? You wouldn't know what the number is. It's not going to be too far from 2 because 9's pretty close to 8, right? If you know a little calculus, you can make a good estimate. But you don't know any calculus right now, or probably not. Hopefully you will, but not going to get it in this course. Okay, what you do is you use laws of exponents, which you can write down in a minute or less correctly, right? As of maybe tomorrow, but I won't get to quiz you on it tomorrow, so make sure you can do it by Tuesday. One of your laws of exponents tells you if you raise a power to a power, what do you get? Well, you multiply the powers. Okay, now you need a more specific statement of it, but 8 to the cubed to the 1/3 is 8 to the 3 times 1/3. And that multiplication sign there almost looks like a minus, so let me make it a little clearer. Okay? And what's 3 times 1/3? Another thing you got to do is fractions, okay? Make sure you got that down. Can't live without doing fractions. Well, it's 1. So that's x to the 1, which is, of course, just x, right? And then what's 8 to the 1/3? Well, it better be 2 because you know the solution to that is x equals 2, right? And we won't worry about why 8 to the 1/3 is 2, because I'm going to say now, if that was 9, you wouldn't have any idea what 9 to the 1/3 is. That's where you use your calculator. Okay? Even for 8 to the 1/3, I don't care. Go ahead and use calculator, get 8 to the 1/3 for right now. Okay? So, you get 8 to the 1/3. If you punch that into your calculator, you get 2. And if you punch it into your calculator and don't get 2, you didn't punch it in right. Maybe you need some parentheses, maybe whatever. Okay? But you should know how to use your calculator well enough to do that.
So 8 to the 1/3 would be the cube root of 8.
Would be what?
The cube root of 8.
Yeah, but we're not talking about, yeah, it is the cube root. That's a radical, and as I said before in the other class, I don't want to talk about radicals much. Square root's about the only radical I really want to talk about right now. Okay? It's the only one you really need. Other than that, I want you to work with rational exponents. Because the laws of exponents apply directly to expressions like this. They don't apply directly to radicals. And I don't think you can really learn radicals until you can do the laws of exponents in this form, because they all are equivalent to laws of exponents. But there's an extra step in there, and I don't want you to have to worry about that step until you really know the laws of exponents, okay? Now, if you know about radicals, that's fine. I still want you to do it with exponents right now. And then go ahead and show off, do it with radicals. You'll understand the radicals better. It can't hurt you a bit, and it shouldn't take long. So, this is what you get. I say, but you've got to use a calculator for most problems of this nature, because you're usually not going to have something contrived to give you a perfect cube here. And you're probably not going to recognize perfect cubes past about 1728, right? Can you list all the perfect cubes from 0 up to 1720? That's 12 cubed, okay? So, you know, it's cubes of numbers up to 12. 11 cubes, 1331, 10 cubed is 1,000, 9 cubed is 729, and the rest are really easy. Okay? But you probably don't know that, and you're probably not going to know that. So you're not going to recognize when you have a perfect cube or when you don't, maybe except for like 8, 27, and 64, and maybe 125. Okay. That's okay. It doesn't hurt to know those things. Depends how much math you want to use and how much you want to be able to do in your head. What about x to the 5th equals 17? What do you do to both sides? Raise to 1/5 power. And it looks just like this one, except you have to use a calculator to get 17 to the 1/5. Then, of course, you raise that to the 5th power to make sure you get 17. Make sure you did it right. You check. X to the 2/3 equals 4. What are you going to do to both sides? You raise it to a power that gives you x. What power of x to the 2/3 gives you x? Anybody? I'll bet some of you know. I'll bet most of you don't. Okay? Just knowing what the algebra courses teach people who don't. I think y'all are probably fairly good at factoring. I think you're probably fairly bad at this. Okay? But this isn't hard. You just got to take the time to get it. Okay? Well, you're going to raise it to a power, mean you have to have a number to multiply by 2/3 to get 1. What do you multiply by 2/3 in order to get 1?
3/8.
3/2, right? So you raise this to the 3/2 power, just the reciprocal power. So then you have this power times this power, and that gives you 1. And if you are a little bit confused by that, you really need to practice fractions. Okay? Because you're insecure in fractions, which most people are, again, coming out of this SOL-driven curriculum. One of the things that isn't learned well because they put a calculator in your hands when you should be doing fractions on paper and in your head. People come out not being very adept at fractions, okay? And it's universal, whole country. But you gotta be in order to understand how to solve these problems, how to solve these equations. And you gotta be able to solve equations. Okay, then we have square root of x equals 6, and you can look at the video on that, but that one's pretty straightforward.